Okay, so we're going to look at parts of the atom now. And there are five main parts that I'm concerned with you knowing. So over the past 2,000 years, the model of the atom has changed considerably, and it has become increasingly complex. One of the more recent models, um, which we're going to study in grade 10, is made up of five main parts. So the first part that things are made of is these atoms are made of protons, and protons carry a positive charge, and they have a mass of 1 atomic mass unit. So on the periodic table, things are measured in what's called AMUs. That's kind of similar to like when you step on a scale, what your weight is. Instead of it being in pounds, it's in atomic mass units. These guys are located in the center of the atom called the nucleus. And the number of protons are also equal to the atomic number. So when we were looking at this picture, the atomic number, what that tells us is that also tells us the number of protons, which is a super nice feature for us. Just so you guys have kind of a picture, what an atom, when we draw it, will look like is it'll have a circle in the middle with a bunch of little positive charges. It'll have a circle on the outside and maybe one or two circles on the outside. Those things are called orbitals. And that is where electrons will exist, but we'll just draw them as shaded in circles. So that's kind of what a atom will look like as we're drawing. Protons, it's also worth noting that they are very heavy, but they're also very small. I also wanted to show you guys, probably as a scientist, the most exciting picture in a really, really long time, but also one of the most boring photographs I've ever seen. So this right here, this is the picture, the world's first picture of an atom. So this little tiny dot in the middle, that is one singular atom. This is a huge, huge magnification. And I'm just trying to figure, strontium, that is a singular strontium atom right there. It's not a very exciting picture unless you're a scientist or unless you care about how significant this is. This picture was taken in 2018. So this was 2 years ago. This is the first time ever in history that we've ever seen what an atom looks like. So that was really exciting for scientists. So we talked about protons. The next thing we're going to talk about is neutrons. Neutrons carry a neutral charge. There's a joke from the Big Bang Theory where Sheldon is talking about a proton, a neutron, and an electron enter a bar. Proton asks how much for a drink. Bartender says, it's $5 for you. Neutron asks how much for a drink. Bartender says, for you, no charge. Really lame joke. I'm really sorry. But that is because neutrons themselves, having a neutral charge basically means that they don't have a charge. And because they're not positively or negatively charged, kind of like a magnet, it doesn't attract or repel anything. It's just kind of this blob that sits there and doesn't do a whole heck of a lot. These neutrons also have a mass of 1 atomic mass unit, so that is the exact same as a proton. And these guys are also located in the nucleus of the atom. So again, the nucleus being the center. So when I drew my atom on the last slide, I would draw a bunch of protons in the nucleus, and then neutrons are just going to be represented by little n's. Those all exist in the nucleus of the atom, and then like we said, electrons exist on the outside of the atom as just little circles. These guys have an equation that they're equal to. So they're equal to the atomic mass minus the atomic number. And so if we were to look over at our little carbon again, if we wanted to figure out the number of neutrons, what we would do is we would say we need to take, so number of neutrons is equal to 12.01 minus 6. And Enoch asked a great question the other day, which was, do we need to round when we're looking at these numbers? And the answer is yes, absolutely. So instead of doing this, I wouldn't do that. I would instead just round up to 12 minus 6. It's impossible for you to have 0.1 or 0.99 of a neutron. You either have a neutron or you don't have a neutron. So yes, you do need to round. And in this case, we would figure out that carbon has 6 neutrons. So 12 minus 6, 12 from the atomic mass, 6 from the atomic number, that totals 6 neutrons. And it kind of makes sense when you think about the actual masses of protons and neutrons. If the atomic mass is 12, and each proton weighs 1 unit, and each neutron weighs 1 unit, in theory, the number of protons plus neutrons, so the number of protons plus neutrons, equals the atomic mass. So because each of these weighs 1 atomic mass unit, again, protons plus neutrons, that should equal the mass. The last one that we're going to talk about is easily the most interesting of all the parts of the atoms, in my personal opinion, and that is the electrons. These carry a negative charge, and they also have an atomic mass of 0.0005 atomic mass units. So these guys are very, very light, which makes them easy to move around in terms of sharing them with other elements that exist, but it also means that they don't have much of an impact on the mass or the actual weight of an atom. As we said, these guys are located on the outside of the atom. And so when I drew your previous atoms, I put a bunch of plus signs in the middle and a bunch of N's in the middle for the protons and the neutrons. These things on the outside here, these are called orbitals. And that is where the electrons are going to exist. They are going to all exist in orbitals. And I'll put a little E minus here, because that's just how, Mr. Nickel, that's how I show electrons. Rather than writing the entire word out, I'm just going to put a little E minus. And a lot of times, if I have colors, I'll make it green as well. I don't know, for some reason, electrons are green to me. Here's another cat meme for you. What did the angry electron say when it was repelled? Let me at him. Really poor. I'm really sorry, everybody. Next part. So we have talked about protons, neutrons, electrons. We're going to now talk about the nucleus. As we said, that is the cluster of nonsense of the protons and the neutrons that exists in the middle. That's pretty much all there is to say about it. There's a bunch of protons and neutrons. They're all clustered around the middle. Orbitals, that's the last one that we're going to talk about here. We've briefly mentioned those already, but that is the area outside of the atom, and the electrons are found there. Sometimes I won't call them orbitals. Instead, I'll just call those rings, or I'll also call them shells. When we get to grade 12, I will probably exclusively call them shells. I won't call them orbitals. The next 3 points here, these are imperative when we're talking about Bohr diagrams. So these ones are imperative when we're talking about Bohr diagrams. And that conversation will happen more tomorrow, and we'll start working on some pictures, and then you guys can work through that assignment that is due Friday, which is the 3 different Bohr diagrams you'll draw. So the critical information is the first shell, this first little ring on the inside here, will only hold 2 electrons. That is also, interestingly enough, let me pull up my periodic table here. The reason that it can only hold 2 electrons is because we only have 2 elements that exist in the first row. So these, hydrogen and helium, those are the 2 electrons that exist in that first little orbital. So if I was to draw a little hydrogen, hydrogen only has 1 electron because it has a little number 1 in the top corner here. So as such, if I was drawing hydrogen, I would put my little H in the middle, and then in this first ring, it would only have 1 electron. Helium, on the other hand, has the potential to have 2 electrons. And that's because it has the little number 2 up in the corner here. So we would know, based on that little number 2, that it has 2 protons. That also tells us that this has 2 electrons. Anyone have any guesses for how many electrons lithium would have? Yeah, 3, exactly. So this little 3 tells me that, yes, there are 3 protons and 3 electrons. But if I want to draw lithium, we know that only 2 electrons can go on this innermost ring. Again, that was showed by the hydrogen and the helium, these top 2 in this first row. So what I have to do then is I have to make an entirely new row, or an entirely new orbital. And in that orbital, I can fit 8 electrons, but I only need to draw 3. So right now I've satisfied lithium. I've drawn 1, 2, 3 electrons. And the reason I drew this second orbital, this second ring, or this second shell is because this first ring can only have 2 electrons. Let's go back to the previous slide. Previous slide said the second will hold up to 8 electrons. And so what we can do then is we can say, well, I know that 1, 2 of these electrons will be in this first orbital. I know that I can fit 1, 2, 3, 4, 5, 6, 7, 8. I can fit all the way up to neon in this second ring. So if I were to draw a neon Bohr diagram, it would look like this. I would draw my 2 electrons in the innermost ring. And I know that neon, because of this 10 in the little corner, should have 10 total electrons. So I can draw 1, 2, 3, 4, 5, 6, 7, and 8 electrons in that orbital there. Now, what I have done is I've drawn these in kind of a funky way. I've drawn these as pairs. I've drawn 4 different pairs of electrons, and there is a reason for that. This example would be much easier to show you in person, but basically what those pairs of electrons will do is they'll exist on opposite sides of the nucleus at all times. So when they're spinning around, they will always go in opposite directions regardless of the 3D direction that they're traveling. They'll always be on opposite sides. And so that's why we draw them as pairs of electrons. The other reason that we draw them as pairs of electrons is because electrons get really lonely and they need a buddy to exist with when they're spinning around an atom. So if we look at lithium, this top little electron up here, he does not have a friend. And so what that means is he's going to be extremely lonely, and he's actually going to want to leave lithium and go to another element. And when we start looking at compounds, we'll see that this lithium will eventually turn into this. It will eventually turn into this, where this electron leaves and it then gets a positive charge. So it's kind of like losing some negativity and becoming more positive. What will then happen is that probably one of the halogens here, I said that these were really reactive and loved to steal electrons. What will happen is one of these halogens will come along and steal that electron from lithium. And when it does that, it makes a bond with lithium. So we'd have a positively charged thing because it lost an electron. One of these halogens would steal that electron, become negatively charged, and then similar to magnets, positive and negative things will attract each other, and we will eventually form a new bond together with those two. So that's looking a little bit further ahead than we need to. But what we can also know is we can know then from Bohr diagrams and from the orbitals that the third ring will also hold 8 electrons. So this first ring holds 2. The next ring, as we said, we pair them up, holds 8 electrons, and then the outermost ring there also holds 8 electrons. So what that means is that using Bohr diagrams, we can go all the way up until argon. After we reach argon, we actually can't draw a proper Bohr diagram any longer. And part of the reason is that when we get into the next ring here, some of those electrons actually, instead of being here, they start to creep in a little bit and they start to take on a different shape. And they start to interfere actually with some of this other orbital here. And so it looks like 10 electrons are in another orbital, but really it's still just this outer ring. That's some Chem 30 stuff. We don't need to concern ourselves with that right now. All that you need to know is that this works up to argon. So that's the absolute maximum Bohr diagram that you can draw on these. And actually it would be 1, 2, 3, 4, 5, 6, 7, 8. Yeah, it would be argon. Perfect. Okay. So ultimately what we want to learn from this lesson is all of the information that's found on this slide right here, which is that the number of protons is equal to the number of electrons, and both of those equal this atomic number. And then in terms of calculating the number of neutrons, we would want to do the atomic mass minus the atomic number. And that would give us our number of neutrons. So likely what will happen here is after we conclude part 1 and you get your exam, you're going to be given a chart like this on your exam. And what I will ask you to do is I will ask you to fill this chart in. And so in order to do that, you will need a periodic table, which is why I gave you one in your materials you may need section. And what you'll do is you will look at each of these little numbers here and be able to fill in all of the boxes. So I'll work through these ones with you right now. And then next week when you get your test, I think it should probably be next week. We'll see. But when we get our test, I'll give you a practice sheet that looks like this, where you get the chance to fill in and practice and ask me questions and see if you did it correctly. So looking at chlorine here, I want to know what the atomic number is of chlorine. That's the first thing that's asked. And I know that chlorine exists right over here. And I know that it has an atomic number of 17. If the atomic number is 17, that also means that the number of protons and the number of electrons should equal 17 as well. So that's a really easy piece of information for you. If you know what any of the protons, electrons, or the atomic number are, you can fill in the rest of this chart. Now, I would fill in the number of neutrons, but I actually need to know what the atomic mass is first. And I will find this atomic mass by looking at this little section here. It says 35.45. And if I were to round that, that would round down to 35. To figure out the number of neutrons, then, I would take 35, I would subtract 17 from that, and 35 minus 17 would give us 18 total neutrons. So what's interesting about chlorine is chlorine has more neutrons than it does protons or electrons, and that's perfectly fine. Let's move on to the second number here. I'll put little numbers beside these. So move on to number 2 here. Number 2 is an atomic number of 15. And what that means is I also know that the number of protons and electrons are also 15. What I don't yet know is I don't know which element this is. So I would start looking over at my periodic table. I would notice that this counts as 1, 2, 3, 4, 5, 6, 7, 8, 9, so on and so forth. So I would trace it all the way down to number 15, which happens to be phosphorus here. And they've asked for this element symbol. The element symbol is just a capital P. Yes, you do need to use capital letters when you're representing these. It would be wrong to use a lowercase letter. The only lowercase letters that exist are when we look at helium, for example, the second letter is a lowercase. So you don't want to use two capitals. And the reason you don't is if I were to put, let's say, CO or CO like that, those are actually two very different things. Capital C, capital O, this is actually an element that you probably have floating around in your house. If you watch The Office, this is what Toby was advertising, some carbon monoxide, which is a toxic gas that floats around your house if you don't change your filters on your furnace. This, on the other hand, this is cobalt. That's an entirely different element and also a really poorly made Chevrolet car. So it is important that you're representing the correct capital and lowercase letters. But anyways, back to phosphorus, we said the atomic number was 15, protons 15, electrons 15. The mass here is 30.97, so I would round that up to 31. And then to figure out the number of neutrons, it would be 31. Ooh, do I have an eraser here? That's the question. don't know if I have an eraser. That's interesting. Let's just delete that. I have 31 minus 15, and that leaves me with 16 neutrons. Awesome. Moving on to number 3 here, I have 12 electrons. So that means I also have 12 protons, and the atomic number is 12. I knew where number 15 was. It was down here as phosphorus, so I'm going to go back to number 12, which is magnesium. So I'm going to put a capital M and a lowercase g. The atomic mass of magnesium right there is 24.31. And again, I want to round that off, so I am just going to call that 24. And then in terms of calculating the number of neutrons, again, that's your atomic mass, which is 24, minus the atomic number, which is 12. And here we're left with 12 as our final solution. And then we can do the last one together. 1 proton means atomic number 1, and number of electrons is also 1. This is the very first element on the periodic table, which is hydrogen. The atomic mass rounded is 1. This one's kind of interesting because we have an atomic mass of 1. We also have an atomic number of 1, and that means that there are 0 neutrons in hydrogen, which is kind of strange. So that's how you figure out the atomic number, protons, electrons, neutrons, and the atomic mass. Does anybody have any questions about those examples?